Everyone, and welcome to lesson 1.5. Today we are going to talk about conditional statements and how to apply the converse, inverse, and contrapositive of them. A conditional statement is an if-then statement that is written in the form of if P, then Q. So we oftentimes say if this, then that. So you'll see P, then Q happens. Now, the P portion of the initial conditional statement is called the hypothesis, and then the Q portion that follows the word then is going to be our conclusion, the Q. And you'll see this set up in the if P, then Q. Note that the hypothesis comes after the word if, we don't include it. Same thing with the conclusion, it comes after the word then, we do not include it. So for this first example, we have this hypothesis or this conditional statement. If you are at least 18 years old, then you may register to vote. What is our hypothesis? What is our conclusion? Well, our hypothesis, the P, will be this portion here. You are at least 18 years old. The conclusion then is you may register to vote. Again, that would be considered our Q. So try these next two questions on your own. Underline the hypothesis, circle the conclusion we did up above. Now, we also need to sometimes write the initial statement in an if-then format. So for this first example, we see, I'll go if you stay. So we see that trigger there of if. We would put, if you go, then I'll go. Sorry. Again, we see if you go, so then we chose to do then I'll go. So we see that if there. The next one says perpendicular lines intersect to form right angles. So we could write that if lines are perpendicular, then they intersect to form right angles. Again, we see on this then the hypothesis and the conclusion in that if-then format. Our last example then says a triangle with all angles congruent is an equilateral triangle. So we would say if a triangle has all angles congruent, then it is an equilateral triangle. So again, writing this so that we see the if, hypothesis, then conclusion. Now, sometimes when we think about our logic, we have this idea of a counterexample, right? We've talked about counterexamples in the previous lesson. And what a counterexample does in these examples is that it will keep our hypothesis true, right? So the hypothesis will stay the same while we find another true conclusion that would disprove the original, okay? Again, the key here is that we are disproving the original conclusion. So the original Q portion. So for instance, if a figure has an arrow, then it is a line. So they're thinking about our geometric terms that have arrows on them. Now we know lines have arrows, but what other figure has a line? Or excuse me, has an arrow on it? That would be a ray, right? We know a ray has an arrow on it as well. So it could be a ray, would be a counterexample. What about if a quadrilateral has a right angle, then it is a rectangle? Again, we want to keep this first part true, but the second part isn't necessarily true. Like on this one, we had something with an arrow that isn't necessarily a line. We had a ray. So for this example, we have a figure, what we would call a trapezoid. Okay, that's another four-sided figure, for instance, that has a right angle, but it isn't necessarily a rectangle. So for this one, we could say a trapezoid with a right angle. Now, what about this next example? You want to try something that is true for part one, right? That it is a school day, but not necessarily a Monday. What would be your counterexample? Now, this next part uses our conditional statements, our original P's and Q's, and we rewrite the order of the sentence. So for the first one, we have what's called a converse. And what a converse does is it switches the original conclusion is now the hypothesis, original hypothesis is now the conclusion. So if Q, then P. That's called, we also have something called negation, where we add the word not, or if there was already the word not, we take it out. And again, we call that the negation. The inverse is when we take the original conditional statement and we, again, negate both pieces. The contrapositive is sometimes called the converse of the inverse, where we're doing both. We're flipping the order and we're negating them. So again, we see this chart, again, kind of with each one, what we're doing to our original P's and Q's. All right, so let's look at some examples, okay? Our original statement is if a figure is a triangle, so a figure is a triangle is our hypothesis, then it is a polygon is our conclusion, okay? And we want to say on this one, what is the converse, the inverse, and the overall contrapositive? Well, the converse, remember, is when we switch the order. So Q is now going to come where P was and vice versa. So on this first example, we would say if a figure is a polygon, so the Q from up above, then it is a triangle. So the conclusion, or excuse me, the new conclusion is the original hypothesis. For our next example, we want the inverse. So again, we're taking the original and we are negating it. Okay, so we're taking these originals and we're negating it. So we're adding in the word not since it wasn't there before. So we would say if a figure is not a triangle, then it is not a polygon. Again, we're adding in, we're negating that original piece we had. Last but not least, we have the contrapositive. So we are taking the order and flipping, and then we are also negating. So we're going to take the original conclusion and negate it. It is now our hypothesis. So if a figure is not a polygon, we have this original conclusion, we would say then it is not a triangle. Now use the next example to try on your own. Again, start by identifying what is our hypothesis and what is our conclusion, and then you will go through and find the converse, where we, switch the order, inverse, where we negate the original, and then our contrapositive, where we flip and we negate. All right, our last piece for today is the idea of a biconditional statement. So what happens with the biconditional statement is not only is if P then Q a true statement, also flipping it around, the converse also ends up being true. What we call this is a biconditional statement, where you see these double arrows because no matter the order, they are true. So for instance, on our first example, we have this statement here. Is this conditional statement a biconditional statement? Why or why not? If a figure is a triangle, then it is a polygon. Well, let's look at the flipped order, right? If Q, then P. Okay. Well, what's happening is if we flip this order of the original and put if a figure is a polygon, then it is a triangle. Is that necessarily true? The answer here is no, because we know that the figure, maybe it's a triangle, but we could also have pentagons. We could also have other quadrilaterals, so four-sided figures. All of these are polygons that aren't necessarily triangles. So again, no, because that would disprove that. On our second example, okay, we have the original conditional statement. If it is Sunday, then tomorrow is Monday. Well, again, if we look at the flipped order here, if we put the Q first, then the P, it would say if tomorrow is Monday, then it is Sunday. Does this make sense? The answer here is yes. If tomorrow is Monday, that has to be true statement that it is Sunday. And we know that this order is also true. So we would say our converse is also a true statement. Thanks everyone for watching. We'll work more in class.